Hello again, everybody. It's now time to look at solving quadratic equations, as you can see here. Basically, this is where we start tying everything together. We start figuring out why we've been factorizing and why we've been doing all this algebra so far. We're starting to apply it. Okay, first up, a little bit of revision. Let's look at just solving a linear equation first. What are we doing? Well, here's one, y equals 3x plus 2. I know it's not quadratics, but just let's get our heads back around this. So we need to use the null factor law. So when we're solving this, or when we're graphing this, we need to do two things. One is let x equal 0, and the other one is let y equal 0, as you can see here. So let's bring down an equation. Y equals 3x plus 2. So we're going to substitute the x equals 0, that 0 in place of that x. So we get y equals 3 times 0 plus 2. So 3 times 0 is obviously 3. Is it? No, it's 0. Did I just say that out loud? 3 times 0 is 0 plus 2, which is, of course, 2. So y equals 2. Now we do the same thing with the y. Bring down the equation. Y equals 3x plus 2. Instead of the y, we'll put the 0. So 0 equals 3x plus 2. Now we need to do a bit of rearranging. So we need to bring that plus 2 over to the other side. What's the opposite of plus 2? Negative 2, correct. So we get negative 2 equals 3x. Now we need to bring the 3 over the other side. So that's 3 times x. And the opposite of times is divide. So it's negative 2 over 3 is equal to the x. So what do we do with them? Well, we draw a graph. Here's some axes. We need to put these 2 points on the graph. So the y equals 2, which is up here. There's the point, and label it 0, 2. The negative 2/3 is down here, round about in here. So there's the point, negative 2/3, 0. And what do? We simply join that graph, join the dots. And there's our straight line, okay, which is y equals 3x plus 2. Now, the bit we're really interested in is only the x-axis, the x-intercept, okay? This is the solution that we're after. Okay, so it's time to start applying this to quadratics. Let's have a look. So what about quadratic equations, you say? Okay, here's a quadratic equation. Y equals x squared plus 4x. Now let's have a quick look at this on the graph. We need to find the solutions. Now remember, the solutions are only the x-intercepts. So here's an x-intercept. So that's 0, 0. And here's the other x-intercept, which is negative 4, 0. You notice how on a quadratic, there are potentially 2 intercepts. That's what makes this a quadratic, the squared. The power up there tells you how many possible, not always, how many possible intercepts there will be. So a quadratic is 2. If that was a cube, you would have, yep, you're right, potentially 3 x-intercepts or 3 solutions. So our solutions for this one are, now remember it's only the x values, so it's 0 there and negative 4 there. There are solutions. All right, we still need to use the null factor law. We're going to do this algebraically. It's great if you've got a graph there, but if you haven't, you can do it algebraically using the null factor law. But remember, we don't need the y, we only need the x's. So that means we just have to use one of them. So instead of the x equals 0, y equals 0, we can just do the y equals 0. All right, let's rewrite our equation. Y equals x. Oh, we don't want the y equals, we want the 0 equals. So let's change it. 0 equals x squared plus 4. Okay, what are we going to shift? If we shift the 4x onto the other side, that becomes negative 4x, and we've got an x there and an x squared there. That's not really what we want. If we shift the x squared onto the other side, it becomes negative x squared, and we've still got the 4x over here. Not really what we want either. So what we're going to do is we need to factorize. Remember all that factorizing you did in algebra? This is where we start to apply it. All right, now, how can we factorize? We've got some rules for factorizing. We have to start with highest common factor. Well, let's have a look at that. Is there a highest, oh yes, there is a highest common factor between that one and that one. There's obviously an x in each of them, isn't there? So let's move that out of the way. Highest common factor is x. Now, if you recall, we'll bring that down. 0 equals, we put the highest common factor out the front of some brackets. Now, we've taken the x out of the x squared, so what's left over? X out of x squared leaves an x. We've taken the x out of the plus 4x, x out of the plus 4x, and we're left with plus 4. Great. This is starting to look like the other side, isn't it? We have two options now. To make this equation true, it's either going to be this x out the front is equal to 0, because that's time. 0 times anything is 0. Or we make the bracket equal to 0. So x times 0 is going to be 0, which will make that equation true. So here's our options. The x at the front's equal to 0, or the brackets equal to 0. So first one, x equals 0. That's easy. That's one of the solutions. Or the x plus 4 equals 0. It's linear now, isn't it? We shift that plus 4. That goes onto the other side and becomes -4. So there are our two solutions. X equals 0 and x equals -4. Let's check it on the graph. The x equals 0, there it is, and -4. There's that one. All right. Now, question. Why do we need to factorize? We need to factorize to turn x squared variables into x variables. So 1x squared can turn into 2 single x variables. All right, probably a good time now, just a quick reviser to look back at our 5 steps to factorizing. Now we need to do these or check for these in order. So the first thing we need to check for is highest common factor. Second thing we need to check for is difference of two squares. Third thing we need to check for is to see if our equation, and this is where we start getting into, well, difference of two squares is already quadratic. Proper quadratic is if it's a monic trinomial. That means there's no number out the front of the x squared term. The next step we look for is non-monic trinomial. That's where there is a number out the front of the x squared term. And the fifth step is, of course, completing the square if it doesn't come out nicely. There is a sixth version, which is using the quadratic formula, but this video is not about factorizing. If you'd like to go have a look at and do some revision about factorizing, head over to the YouTube clip on Marby Maths. There's the hyperlink to it. And here's a quick screenshot where you can see this one was the monic trinomials. And we've just gone through how to solve 4 monic trinomials with the steps. It goes through all of these things and, as a bonus, the quadratic formula. Next, let's have a look at some examples of what we're doing with solving these quadratic equations. We could be lucky. Here's a couple that are already factorized. In that case, we've got our x equals x plus 2 and our x plus 3. Great. So it's either x plus 2 equals 0 or the x plus 3 equals 0. So we split it up. X plus 2 equals 0. Shift the plus 2 becomes x equals -2. Same deal here. We've got our x plus 3 equals 0. So we shift the plus 3 and it becomes -3. So these are our two solutions. Down here, we've got the x out the front again. So that's like the other one we did. Either the x equals 0 or the brackets equal 0. So we have x equals 0, that's done. Or we have 4x plus 5 equals 0. Shift the plus 5, goes over to the other side, becomes -5. Then we shift the 4, so that's times. Opposite of that is divide, so we get x equals -4/5. So our solutions are x equals 0 or -4/5. Right, now what if they're not factorized? Okay, this is where we have to think back to our factorizing laws, so we can factorize it. So, first up, is there a highest common factor? No, there's an x squared, there's a 16, there's no x's combined. Okay, can't do that. Is it difference of two squares? This one, x squared, well, that's definitely a square. 16 is a square. Great, that's two squares, and that's a minus, which is difference. So it is definitely dots. How do we do that one again? Well, we need to find the square root of the first one, which is square root of x squared, which is just x. Then we find the square root of the second one. Square root of 16 is, remember, it's plus or minus 4. Positive 4 squared is 16. Negative 4 squared is also 16. All right, so we can write these out. If dots, x plus 4 is that one, or x minus 4 is that one. Solve the same way. That could be equal to 0. So that becomes plus 4 goes over this side. So it's x equals -4. This one, x minus 4 equals 0. So this goes over the other side and becomes +4. So there's our two solutions. Now, with these ones, I'm going to do you a favor. I'm just going to give you a quick look at what the graphs look like. Let's see if it's true. Here we go. Let's check. Now, again, down here, not worried about the y-intercept. What we are interested in is the x-intercepts, 1, 2, 3, 4, and -1, -2, -3. That's right. Awesome. Let's look at the next one. Highest common factor. No, because you got the 8. There's x in there, there's an x in there, but there's no x there. It has to be across all three. Is it difference of two squares? Well, there's definitely no difference in there, is there? And there's 3 terms. So, is it a monic trinomial? There's nothing out the front. Technically, there's a 1 out the front, meaning mono. So, yes, it is a monic trinomial. Remember how to do this? We have to find the 2 factors of 8 that will also add to 9. Luckily for us, 1 times 8 is 8, and 1 plus 8, or 8 plus 1, 8 times 1, and 8 plus 1 is 9. So there are our 2 factors. So we simply rewrite it as x plus 8, x plus 1. Do each one individually. So we do the x plus 8 equals 0. Therefore, x is going to equal -8. This one, bring down the x plus 1. Obviously, plus 1 goes the other side. It becomes -1. There's our other solution. All right, let's have a look at this graph. Here we go. Oh, there's the graph. Check it. X equals -1. There's -1 and -8, -2, -3, -4, -5, -6, -7, -8. I think whoever was drawing this graph could have been a bit more careful with their ruler on this one, but you get the idea. All right, this third one, that looks a little more interesting because we've got x squared, x, we've got the 10, we've got 1, and the -3. Well, it's not equal to 0, is it? So what we have to do is we have to shift everything over onto one side to leave nothing on the other side. So what's going to go first? Let's shift that -3. -3x, sorry. What's the opposite of -3x? All right, plus 3x. So rewrite it with plus 3x. Let's simplify that a bit. We've got the 3x there and we've got the 3x here. So 3x and 3x is 6x. So let's rewrite that. X squared plus 6x plus 10 equals 1. Now, of course, we have to shift the 1 over the other side. That's +1 becomes -1, correct? And leaves nothing over there. We can simplify the 10 minus 1, which becomes x squared plus 6x plus 9 equals 0. Just before I go any further, you noticed in this equation in particular, but generally speaking, all the equal signs line up. That just makes it so much easier to see what you've shifted. Okay, try to line up the equal signs. Okay, what do we got now? Monic trinomial, same as this one, wasn't it? So let's write monic trinomial here. Factors of 9, that will add to 6. Let's see, 1 times 9, 1 plus 9 won't get near 6. 2 doesn't go in. 3 times 3 is 9. 3 plus 3 is 6. 3 times 3, 3 plus 3, they are our factors. Great. So we write it, x plus 3 equals 0. Now we've got 2 of them, 2 of the same thing, haven't we? That doesn't matter. We can rewrite that as x plus 3 squared. That squared out there doesn't matter so much. It's what's in here that matters. Because all we need to do is make that bracket 0. And then it's all equal to 0. So x equals -3. -3 plus 3 is 0. So x equals -3. It's pretty straightforward, really, isn't it? Let's quick look at the graph. Here it is. So -1, -2, -3. All right, well, that was our solution. All right, there's all sorts of other things that you can do. Heaps of different factorizing, the non-monic, the completing the square, all works exactly the same way as these 3. Last bit, let's go back to the first equations, first questions we had, back to the start. Solving quadratic equations. What's the point? Well, the point is we need to find the x-intercepts on a parabola, which are the solution. That's why we're doing it. Why do we factorize? Because we want to change x squareds or cubes or quartics into individual x's, which will give us those solutions. All right. Hope this has been helpful. If you get stuck, please remember, ask your teacher. Go back and have a look if you need some factorizing practice at the Marby Maths YouTube channel. Otherwise, good luck.